So let's continue from question 21. It says it's given that OA, vector OA equals to 3p minus 2q, vector OB equals to p plus 7q. Find vector AB in terms of p and q. Okay, so how do you do this? So 20 and 21, that's part A. And when you're asked, this is a very common question, so take note of it. When you're asked to find AB when you're given these position vectors, what you do is you take the vector, the position vector of the second letter. So the second letter is B, so the endpoint, and then minus the position vector of the start point. Start point would be OA. You're going from A to B. So the position vectors for B and A, you subtract those. The position vector for B comes first. Okay. So here you just substitute P plus 7Q. When you substitute, just use brackets, okay, just in case. Okay, so you get 3p here minus 2q. You see, this is an example of why you need to use brackets when you substitute, just because sometimes there's hidden this negative affects this one, but then if you don't use bracket, then you won't be able to see that. So you want to avoid that mistake, okay? So that mistake. So this one will be 2q. This step, you just this one minus p minus 3p, you get negative 2p, directed numbers. Then this plus this, you get 9q. And this is it. This is your answer. Done. That's for the first part. What does the second part say? Second part says given that AB equals to 3mp plus m minus nq, find the value of m and the value of n. So these are just constants. These are our vectors again. So AB we have already calculated to be this. Okay, so you can say by equating the vectors. So by equating the vectors. So by equating the vectors, what do you get? You get this one is just an arrow. Don't get confused. So negative 2p plus 9q, like this. It's equal to 2mp plus m minus nq, like this. Done. So by equating this these vectors, you have this. Okay. So by inspecting p, I'll explain to you just now. Vector p, by inspecting, you can even say vector p. By inspecting vector p, like this. So what does it mean? Here you have your vector, you have your vector. These are the same vectors. So vectors are such that the x component and the y component, the horizontal and the vertical components, they are independent of each other. So that means this part here with p is equal to this part here with p. The coefficients are the same. So by inspecting vector p, you get negative 2 equal to 2m, like this. Then you divide both sides by 2, then you get m equal to negative 1. Then this is it. You divide both sides by 2. Okay, let me just do it. So divide by 2 here, divide by 2 here. So you get 1 here, so you get m here. So that's where we're getting the negative. So this 1 in the negative gives you negative. So that's it. And you are asked to find m and n. So we just found m. So you also do the same thing. So by inspecting, this time we're inspecting what? Vector q. So by inspecting vector q, this is what you find. You find that 9 equal to m minus n. Okay, this part here. So 9 equal to m is negative 1. So negative 1 minus n, like this. This n can go to this side, transposition. So n equal to negative 1 here minus 9. So what do you get? You get negative 10, like this. So if you want, you can conclude m equal to negative 1, n equal to negative 10. And that's it, you're done. Let's move to the next question. So the next question says, in the diagram PQR, this is a triangle. for which this angle is equal to 30. So PRQ. So PRQ is equal to 75. This one is equal to 30. So that's RPQ. So this one is equal to 30. You're given this, take note of the units. Okay, the units are in centimeters, and you're asked to find PQ. So part A, we have to find PQ. So whenever you have a triangle, just look at it this way. If it's a right angle triangle, you use trigonometrical ratios or use Pythagoras theorem. If it's not a right angle triangle, you can use cosine rule or sine rule. And here's the thing, you only have one side here. Normally when we use cosine rule, we have two sides sandwiching an angle. That's a hint that you're supposed to. If we had 7 here, that would be a hint that we are supposed to use cosine rule. It's not always the case, but it's almost always like that. So if you have a side and a corresponding angle, usually it's sine rule. So you have side facing an angle. So that's sine rule, okay? So just look for what you want. You want PQ divided by the sine of the corresponding angle, side corresponding to PQ. PQ here, it's 75. Equal to, then we have any corresponding side and any side angle combination. So this one would be 8 over sine 30. So you'd get PQ equal to 8 over sine 30 degrees multiplied by sine 75 degrees. So you get 8 over sine 30, it's 0.5. Okay, multiplied by sine 75. Sine 75 we're given, it's this one, so 0.97. Then here, this one divided by this. If you want, you can multiply top and bottom by 10. So you get 80 over 5. 80 over 5, you get 16. If you want, you can just say divide by 0.5 means multiply by 2. So you get 16 multiplied by 0.97 like this. So you just do it on a small piece of paper. So that's 97. How many decimal places? 2. This is a primary school method. So here you get 0, here you get 54, 4k, 5 here. Then you get 9, 9 plus 5, then you get 410. Then here and here you get 42. So 2, 4. Then here you get 7 plus 4. You get 11. Then you add this. What do you get? You get 2 here, you get 5 here, you get 5 here, you get 1. 2 decimal places, remember. Then you get 15.52. So you're supposed to get 15.52 to what? 3SF. Okay, and you're supposed to specify this. So you're supposed to specify that it's 15.52 what? Centimeters. Okay, it's 15.52 centimeters. So make sure that you highlight this. And that's it for this part. So it's 15.52 centimeters like this. And the second part, you're asked to find the area of the triangle. So area of the triangle, it's equal to area is equal to its half any two sides sandwiching an angle. So it's similar to what you use if it were cosine rule. So half any two sides, so that's 8, any two sides sandwiching an angle. So 8, 15.52, then sine the angle sandwiched. Okay, so here you get 4, 15.52. Okay, sine 75, it's what, 0.97. So if you want, you can even approximate this as 1. So if you approximate this as 1, then you get 4 by 15.52. So just put the approximate sign such that you're approximating. So you say multiply by 1 here. So you'd have 15.52, these are 2 decimal places, multiply by 4. So here you'd get 8, you'd get 20, you'd get 22. So here you'd get 3. 2 decimal places, thus. So it would be approximately what? 32.1 what? Square centimeters. Then you say 3 SF, 3 significant figures. Okay, so don't forget the units, don't forget the units here. For area, the units are square. So that's it. Let's move to question 23. So question 23 says you have masses of 20 patients at a hospital. They're shown in this diagram. Calculate as an estimate the mean of the mass of the patients. I don't know my editor here. So the mean, how do you find it? So the mean is for the mass, so we can say m bar. So m bar would be equal to, you take the median. So from 60 to 70, the median would be 65. Multiply by the frequency. The frequency are the number of patients. Okay, so you're supposed to check the sum of these items. So here it's plus, here would be 75, multiply by 8, plus here would be 85, and here would be 90 rather. 90 multiplied by what? By 5. Then divided by the total frequency. The total frequency is 20. So 7 plus 8, that's 15 plus 5, that's 20. So you can get this as a train, or you can just try to divide beforehand. So for example, 5 is a factor through and through. So you can say 5 into 6, that's 1. Remember 1, 5 into this, that's 3. So you get 13 by 7 here. So 5 into 75, 5 into 7, that's 1. Remember 2, and that's 5. Then multiply by 8 here. Then 5, this one goes away, so 90. And then divided by what? By 4. So notice what we did was we divided throughout by 5, and also divide the denominator by 5. And if you don't want to do this, just calculate and then add and then divide by 20. But I'm just showing you this method because it's faster. So what do you get? 13 plus times 7 times 10, you get 70, plus 21, you get 91, plus 15 by 8, 15 by 4, you get 60, 60 by 2, you get 120. Yeah, this is just arithmetic, so just do whatever you feel comfortable doing, but then just make sure that you get the correct answer. And here you get 181, so 180 plus 120, you get 200 plus 1, 201, divide by 4. Then here you get 5.4, that's 1, into 20, let me just do it, that's 5, remainder into 0, into 1, that's 0, remainder 1, into 10, that's 2, remainder 2, into 20, that's 5. Okay, and it's in what? It's in kgs, because we're talking about mass. And this is the answer. You're done. So the second part says 2 patients are chosen at random from the 20 patients. Find the probability that both have masses greater than 80. So here there are 2 ways to go about it. You can assume that it's with replacement or without replacement. So assuming, I'm going to do the harder case, but there is no replacement. Required probability P is equal to, so here the buzzword is both. If they say both or and, usually it means you are multiplying. So yeah, it doesn't mean that if they're independent events, then you could add, it would say or something. So here would be probability of m being between 180 and 80. So multiply by probability between 180 again. Okay, so this one here would be 5. Okay, the frequency of occurrence divided by total frequency. which would be, for our case, it was 20, multiplied by, then if we had already chosen one patient, then we're left with how many patients? 19. So now the total frequency would be 19. And then the number of people that we want in our class is what? Our weight class. It's what? It's 4 now, because we've already chosen one other person there. So here you get 5, here you get 4, here you get 4, here you get 1. So you actually get 1 by 19, like this. This is the probability. And also just so you know, probability cannot be greater than 1. So it's just something to know there. So the matrix thus represents a transformation X. And in the A part, you're asked to find the image of a point thus under the transformation. Okay, the new point would be equal to, you take the odd point first. So you take the odd point first, then you multiply by the matrix. So new point would be, you can say image as well. So you say image of the point equal to, so the image of this point, it's equal to what? It's equal to, we take first our point. So our point is -1, 4, like this. Just write it in matrix form. That means you have to get rid of the semicolon. And this is 3, 0, 0, 3, like this. And row by column. So this by column. So it'd be, let me just write it all. Okay. So it'd be -1 by 3 plus 4 by 0, like this. Then this one would be -1 by 0 plus 4 by 3, like this. So you'd get -1 by 3, which is equal to -3. Then here you'd get 12. So you can hold on a little bit on putting this. So you get 12. So therefore, the point is what? -3, 12. This is your new point. Okay. So describe the single transformation for x. So this one here, if you see there's a number, what it means, this one is called the x-axis scale factor. This one is called the y-axis scale factor. So for any scaling, the matrix is this. So you're supposed to recognize that this is a scaling matrix. If there's 1 1, then it's different. But then if you see that there's a number here, this is a scaling matrix. So scaling can be a shrink or it can be an enlargement. If k is greater than if k is greater than 1, this means enlargement. Okay. If k is less than 1, this means shrink. Like this. So this one, it's an enlargement. It's a scale. It's a scaling thing. So this one, it's an enlargement. This is the description, and then you have to say the scale factor. Scale factor is what? It's 3. So you can say scale factor k equal to 3 or scale factor 3, and then that's it. You're done. So that's the single transformation. This one, it's a scaling in the x-axis. This one is a scaling in the y-axis. If they are the same, that means that scaling, it's an enlargement, perfect enlargement. If they are the same, that means that scaling can be a shrink as well, depending on what the value of k is. Greater than 1 means that the scaling is enlargement. Less than 1 means the scaling is shrink. So let's quickly move to the next part. So given that x and y are integers such that x is between -4 and 1, and y is between 4 and 8. So find the greatest value. So when it says greatest value of a fraction, what you want to do is you want to have the denominator is high as possible. So 3 over 1 and 5 over 1, obviously this one is bigger. Okay, so you want to have y as large as possible. I'll tell you one exception when this is not really the case, because these are non-routine questions, so you have to be like real thoughtful in answering them. So we want to take the highest value here. It should be 8. Yeah, so 3 here in the denominator. Now let me illustrate again. 1 over 3 and 1 over 3 and 1 over 5. Which one is bigger? It's the opposite. Okay, so the one that has a smaller denominator is the bigger. That is if the numerators are the same. So we want a very big denominator, or we want a very small denominator in order for us to get the greatest value. So the small denominator here, some people they'll think it's -4, which would be correct in some way, but then you're supposed to take 1, and the reason you're taking 1 is that 1 is positive. It's a positive integer. Okay, if you take -4, that means that this value would be negative, so that would become like a problem. And if you take -1, that will become negative again. It won't be the greatest value. To definitely be the least value. So for greatest value we get 16 over 3 like this. So if you want, you can even put it be 5 and a third, I think, and this is done. And well, let me just show you. If they say list value, okay, what would you do, so that we illustrate this very much. So it's 2y over 3x, so which is equal to, so list value would be, for our y values, they're like this. So we want a value which is as small as possible, so we take 4 here. Here we want a value which is as small as possible again, so as small as possible, such that this is what can I say, the denominator should be, if you want list value, that means the denominator should be as small as possible, or it can be negative. So the smallest negative number here would be -1. Okay, so this is what you take. So you'd actually get -8 over 3, which is equal to -2 and 2/3, like this. This would be your list value. If you put -4, you're making it closer to 1, closer to 0, so it would be bigger. So if you put let's say -4 here, you'd get 4 and cancel this one, you get -2 over 3. Okay, so these are non-routine questions. You have to be like really careful. Just analyze the question. Sometimes if here there was a negative, there was a chance that would have used negatives here. If you don't know how to go about it, you just compare. You can take the extremes, then get the answers, and then get a sense of how the numbers are changing. So just so we are clear, this is how you're supposed to work out this. The other one I was just illustrating. Okay, so on the B part, this is a very common question. You have to separate this into 3 parts. Okay, so if you have these 3 parts, the middle part is always common. You want to create 2 inequalities from it. So you take 1 and 2 first, so you get x minus 2 less than or equal to 4x plus 1. I always advise people to shift this such that you don't create any negatives. So I'd actually prefer shifting x to the side. If I push this one to the side, then it becomes a bit of a problem. It's solvable, but then it becomes a bit of a problem, because when you divide, you might forget to change the sign as well. When you divide by a negative in inequalities, you're supposed to change the sign. So here we divide by 3, you divide by 3, then you get x greater or equal to -1, like this. So this is not done. Okay, now you take 2 and 3. This one, it's a whole term. Okay, it's not just 1, it's not just 4x, it's the whole term. So 4x plus 1 less than 2x plus 4, like this. And now we're going to shift this one to the side. because it's more convenient, right? So that we don't create any negatives. So here we get 2x. Here we get 3. Divide both sides by 2. Divide both sides by 2. We get x. 3 over 2, like this. That's it. So you have to combine those. And what you do is just notice that here this one is the bigger number, so it should come here. And then here, this is facing towards x. So make it face towards x. And then here would be 3 over 2. This is facing away from x. So it'd be like this and this. And then you've combined the two. Okay. And when you're asked to, just out of interest, when you're asked to show this on a number line, this is how you do it. You just -1 would come first. So here, -1, and it's a strict sign. So you do like this, it should be shaded. Okay, so this one would be -1. And then up to 3 over 2. 3 over 2 must not be shaded, okay? So 3 over 2 here. And then this one is your x. So this one would be how you represent it on a number line. But it wasn't asked for a case. But then it's almost always asked, this one. So just take note of it. Let's quickly move to the next question. Question 26, we have this. So the Venn diagram, it shows the universal set with its subsets A and B. The numbers of elements in each region are expressed in terms of x as shown. Write the expression of x for number of A union B. Okay. So these are number of elements. So you're asked to find, for the A part, you're asked to find number of A union B, like this. So A union B just means that we have to add everything that's inside there. So it'll be x squared plus 12 minus x plus 16 plus x. The reason we are doing this is when you're uniting sets, A and B means everything that's in A and B. You're combining them, okay? So you actually get x squared, this one's the cancel, then plus 28, like this. So you get x squared plus 28. Let's, this one will be your answer. Let's see the next question. The next question says, okay. So let's see. Next part says, given that a number of universal sets equal to 40, form as an equation. It was supposed to form an equation in x and show that it reduces to that. So x squared plus 4x minus 12. So minus 12, then we have to show that it reduces to that. So number of universal set is what? It's 40. So B part 1, we are given this equal to 40. Okay. So number of universal set is 40. It's also equal to x squared plus 28 here. This part. Plus these ones, they combine A and B. But we also have this one here, this 4x. So we also have to add it. Okay. So you put everything to one side, you get plus 28 plus 4x minus 40 equal to 0. Then you get x squared plus 4x minus 12 equal to 0. So which is shown. Okay, this is the equation that you required. Yeah, so this is sure that it reduces to this. So it's quite okay. So the next part says solve the equation. See, part 1 says solve the equation. Okay. So we now have to solve this equation. So see part 1, we have x squared plus 4x minus 12. And what I advise you, this one should be, we don't have any coefficient here. So the coefficient is 1. So you don't have any number written here. The coefficient is 1. So for our case, the product equal to negative 12. The sum equal to 4. So what you do is just take the product. You can even ignore signs for now. And then just express it as a product of any two numbers. So 12 and 1, there's no way that we can use them to get 4. So you can divide this by 2, then you get 6. This one you multiply this by 2, then you get 2. So 12 can also be expressed as 6 by 2. And 6 by 2, we can use this to get negative product and also to get 4. This one just has to be negative. Okay. So 6 minus 2, you get 4. 6 times minus 2, then you get negative 12. And so it would come off as this. Plus 6 x minus 2, this equal to 0. And then you get x plus 6 equal to 0, or x minus 2 equal to 0. Then x equal to negative 6 or 2, like this. Then obviously you're done. So this is how you'd solve the equation. Then it says calculate the number of A complement intersection B. Okay, A complement intersection B, so that's C2. Number of A complement intersection B, like this, which is equal to A complement, which means region outside of A. If you want, you can even show it. Let me show it. The region. Let me use a blue pen here so that it's not very visible. A complement would be all this part. It means everything else except for the region in A. So even this part here, you shade it out. Yep, yeah. So intersection B. B is this part. So you can, since you're investigating intersection, you can use diagonal or the lines slanted in the opposite direction than the lines that we're doing. So you get this. And then what do you notice? This is the intersection where the lines cross. And then in the intersection we have what? We have 16 plus x. So 16 plus x. So this one will be 16 plus x, which is equal to 16 minus 6 or 16 plus 2, which is equal to 10 here, or here you get 18. And just so you know, yeah, just a correction somewhat. You see here, these are the number of elements. So the number of elements cannot be negative. So x cannot be negative, like 24 here. You can't have negative 24 elements. So this one we cannot use it. Okay, just an error of caution. So if we can't use this one, your correct answer would be this one here. Okay, so your correct answer would actually be 18, like this. So just be careful. Sometimes you get, and the hint, let me see if there was a hint in the question. So the hint was that ants find this and then you had 1 mark. If you have 1 mark now, it usually means that they require 1 answer. So they actually want you to decide against the other answer there. So yeah, that's it. Let's move to the next question. So the diagram represents the plan of a floor of a room. All dimensions are in meters and all marked angles are right angles. Okay, so let's see. Find the perimeter of the floor. So perimeter first. What's perimeter? Perimeter equal to distance right round a shape. So you can start here going this way. So you have 6, those are meters, plus 7, those are meters, plus this one and this one. If these are parallel, and this is somewhat rectangular because you have right angles. This one should also be 6. This one should also be 2. Okay. So 6 plus 7 plus 6 plus 2 plus 1 plus 3 plus 1 plus 2, like this. So here you get 13 here, 19, 23 up to here. Okay, so let me start over again. Here you get 13 plus 3, you get 19, 21, 22, 25, 26, 28, 20 what meters. Let's just double check. Okay, so here you get 12 plus 14, 12 plus 14 you get 26, then you have 1 here, so 28, which is correct. Let's see what the next question asks of us. So the area of the floor. So this one was part A. Let's move to question part B. Area equal to. So what you can do is you can find the area of the whole shape, and then you subtract this area here. If it's paper 1, you can even write that this is your area A, this is your area B. So let me just write area A minus area B, like this if you want. So this one will be your area A, this one will be your area B. So which is equal to 6 by 7 minus this one is equal to 3 by 1. So 6 by 7 you get 42 here, minus 3 you get 39. 39 what? Square meters. So like this, and it's done. Okay, so this is your area. Let's see what's required of us again. The number of tiles that can be fitted on the floor if the area of each tile is 625 square centimeters, 625. So here we have this area, and now we are told that the area of tile, so area of tile, it's equal to 625 square centimeters. Okay, today my handwriting is very lousy. Square centimeters like this. So you need to divide this. This is just a simple ratio. So ratio problem, proportion problem. So each one is 625. You want to know how many fits in 39 meter squared, in 39 meters squared of area. So the problem is that this is in meters squared. You have to convert this to square centimeters. So how do you do that now? Area equal to, so you have 39 square meters. You want to change this to square centimeters. If you want to change meters to centimeters, what do? You use the conversion ratio. Conversion ratio is equal to 100 centimeters per meter. This is called the length scale. Okay, the length ratio or the length scale. But then you need the area scale or the area ratio. So you have to square this. This is very important. If you're converting volume, then you have to cube this. Okay. Okay then. So here you get 39 square meters multiplied by, that's 10,000 square centimeters over square meters. These ones they cancel now. So units are very useful sometimes, because that's how you find answers. So that's how you find methods. So if you're dividing something and then you want to know the units of the answer, so you can use the units that you're given, such that you know how things cancel out and all that. So number of tiles, you can say let number of, just write in 4, okay, tiles be n, like this. So n equal to 390,000 square centimeters. Let me actually give some space to this, because we will be doing a lot of working out. So n equal to 390,000 square centimeters over, was it 625 square centimeters, like this. So you can use 25. It's a common factor here. So 25 into 39, you get 1, remainder what? Remainder 14. 25 into 140, you get 5. Remember what? Up to 125, that's 5. So remember, up to 40, you get 15, I think. Yeah. Into 150, you get 6. And then into 0, 0, 0 here, like this. And then 25 into 62, and you get 2, remainder 12. 25 into 125, get 5. Okay. So 25 again, into 25 you get 1. Into 156, you get 6, remainder 6. Into 60, you get 2, remainder 10. Into 100, you get 4. So you actually get 624. So n equal to 624, like this. Okay. So that's it for now. If you have any questions or anything, just put them in the comment section, and also make sure you like, share, and subscribe.